Hello students, now I'm going to explain JW Mains 2024 January questions from thermodynamics. First question, they asked in 27th Jan shift 1, if 3 moles of an ideal gas at 300 kelvins expand isothermally from 30 decimeter cubed to 45 decimeter cubed against a constant opposing pressure of 80 kilopascal, then the amount of heat transferred is. When the reaction takes place isothermally, then delta U is equal to Q plus W. For isothermal process, delta U is equal to 0. When delta U is equal to 0, W is equal to Q is equal to minus W. So they asked heat transfer, right? So now W is equal to minus external pressure into delta V. So now Q is equal to minus of minus external pressure into delta V. Minus into minus plus, then Q is equal to external pressure into V2 minus V1. External pressure they given 80 kilopascal converts to pascal multiplied by 1000 into V2 minus V1. So V2 is 45, V1 is 30. 45 minus 30, 50. Then it is equal to 80 into 10 to the power of plus 3 into 15. So then it is equal to 1200 into 10, not 1200, 120, sorry, 1200 into 10 to the power of 3 pascal converts to joule, that further divided by 1000, then 1200 joules. It is the answer for that question. Next, second one, for a reaction, for a certain reaction, thermochemical reaction M gives rise to N at 400 kelvins, delta H 77.2, delta S 122, log equilibrium constant, log K is dash 10 to the power of minus 1. What is the value of that? Now take a reaction, delta Z is equal to delta H minus T delta S. Another equation, delta Z equal to minus 2.303 into nRT log Kc. Substitute this one in this, then minus 2.303 into n value 1 RT into log Kc is equal to delta H minus T delta S. Substitute the values, minus 2.303 into R value 8.314 into log Kc is equal to delta H value they given 77.2 kilojoules converts to joules plus 10 into 10 to the power of 3 or into 1000. Then temperature, here also temperature is required, we didn't mention, minus 2.303 into 8.314 into temperature 400 into log Kc. Delta H 77.2 into 10 to the power of 3 minus temperature 400 into delta S 122. Simplify this, then log Kc will get that is 3.708. So in power minus 1, 37 into 10 to the power of minus 1. Here that's why the answer is 37. Next, third one, which of the following is not correct? Delta G is positive for non-spontaneous, that is correct. Delta G is negative for spontaneous, correct. Delta Z is positive for spontaneous, no, it is wrong. Delta Z is negative for spontaneous. Delta Z is 0 for reversible reaction. That's why option 3 is correct. Next, standard enthalpy of vaporization of for CCl4 is 30.5 kilojoules. Heat required for vaporization of 284 grams of CCl4 at constant temperature. So it is a cross multiplication question. So now molar mass of CCl4 is 154. To vaporize 154 grams of CCl4, so 30.5 kilojoules heat required. To vaporize 284, how much required? Do cross multiplication. So now 284 into 30.5, 154, that is equal to 56.24 kilojoules of heat required. 56.24. Next question, graph the given pressure versus V graph. An ideal gas undergoes cyclic transformation starting from the point A and coming back to the same point by tracing the path A, B, C to A showing in a diagram above the total work done in cyclic process. For this triangle, total work done for this triangle work is equal to minus 1 by 2 into height into base of triangle. 1 by 2 into height of triangle A to B, that is 30 minus 10. 30 minus 10, that is 20. Into base of triangle C to A, 30 minus 10. So now total 40 by 2, 20. Here the answer is decimeter cube converts to kilopascal, meter cube kilopascal converts to pascal. Kilopascal decimeter cube. Next question, two reactions are given below. Fe 2Fe plus 3 by 2O2 gives rise to Fe2O3. Enthalpy change minus 822 kilojoules. Consider it is equation 1. Next, C plus of O2 gives to CO. Enthalpy change minus 110. Equation 2. The enthalpy change for the reaction. To get this reaction, multiply the equation 2 by 3, then we'll get minus 110 into 3. Next, that is minus 330. Next, reverse the equation 1. Then we'll get plus 822. Plus 822 minus 330 will get minus 492 kilojoules. That's what the answer is, minus 492. Seventh question, Consider the following reaction at 298 kelvins. 3 by 2 O2 gives O3. Kp 2.47 into 10 to the power of minus 29. Enthalpy of the change in Gibbs free energy of the reaction in kilojoules. Delta Z is equal to minus 2.303 RT log Kp. Substitute the values. Minus 2.303, R value 8.314, the value in kilojoules, minus 3 into temperature 298 into log Kp. Kp value 2.47 into 10 to the power of minus 29. Simplify these values, will get minus 163.187 kilojoules. Answer is 163.18 kilojoules. Next, eighth one. If 5 moles of an ideal gas expands from 10 liters to volume of 100 liter at 300 kelvins under isothermal and reversible condition, the work done is. So for that, formula is W is equal to 2.303 nRT log V2 by V1. So now substitute the values. 2.303, N value 5, R value 0.0821. If the value in joules, 8.314 into temperature 300 into log V2 100, V1 10. Simplify this, will get 28,730, 28,700 joules will get, that is minus. Here also minus. Next, choose the correct option for free expansion of ideal gas under adiabatic process. For adiabatic process, W is equal to Q, that is equal to delta T, that is equal to delta E, that is equal to delta H. The entire term is equal to 0. That's why second option is correct. Next, 10th one. For a certain reaction at 300 kelvins, K is 10, then delta Z of the same reaction. Delta Z is equal to minus 2.303 R log K. So substitute the value. Minus 2.303, R value 8.314, in the unit in kilojoules, that's why into 10 to the power of minus 3 into temperature 300 into log K. K value 10, log 10 value 1, then minus 2.303, 8.314 into here two zeros, and here minus 2 will get cancelled, 10 to the power of minus 1 into 3. Then simplify this, will get 5.74 kilojoules. So in this expression, 57.4 into 10 to the power of minus 1 kilojoules. That's why the answer is 57.4. into 10 to the power of minus 1.